Good afternoon, everyone, and welcome to today's live webinar hosted by Information Age in partnership with Neo4j. As mentioned, I'm Nick Ishmael, and I'm a reporter for Information Age, and I'll be chairing today's proceedings as we delve into digital disruption and the use of graph databases in the financial services world. Financial services firms are facing new challenges in the form of addressing cyber threats, fighting financial crimes, and ensuring compliance with evolving regulations. Meanwhile, the continuous digitization of processes requires financial firms to evolve their customer engagement strategies. The incredible complexity of interdependent systems within financial assets creates a regulatory compliance nightmare. Compliance requires financial services firms to have visibility into data, information, and process flows, which can be challenging when the same data is replicated across many different systems. It's clear that financial services firms can no longer get away with just conducting business with data locked away in silos throughout the organization. What's needed is an easy way to tie together data from these disparate systems and the ability to derive value from data relationships. The industry is beginning to experience the impact of graph databases across a variety of functions. Just to quickly reiterate what Hugh said, there are some excellent white papers on this subject that you guys can all access, so feel free to download them throughout the talk. And there is also a Q&A box where you can submit questions, and hopefully we'll get round to all of them at the end of the talk. So today we have two speakers for you. Richard Pike, who's CEO of Governor Software. He has an extensive experience of working with financial institutions throughout the world. And Alastair, who was head of design and architecture for risk systems at the Royal Bank of Scotland and head of enterprise data distribution infrastructure at Barclays Investment Bank before joining Neo4j as Director of Product Management. So without further ado, I'd like to hand over to the first speaker. Over to you, Alastair.
Thanks very much. In fact, you've covered a number of points in my talk. Very sort of apposite introduction. So hi, everybody. Thanks very much for attending the call. I'm going to talk a little bit about some of the ways in which Neo4j and graph databases are applicable, particularly in the financial services sector. As already been mentioned, I've got some background in working in that arena and looking at sort of complex data problems within large-scale financial services organizations. So I guess the way I think of it is that in financial services technology, there are sort of, three or four key areas that people have to address. There's the, historically, the core problem of revenue generation, but the increasingly important problems of asset protection, of control, and the extension of control into compliance, and the sort of the massively increased regulatory and compliance environment that, rightly financial services firms are subjected to. Given the risks that are associated with, with the danger of systemic failure, or even, the risks or losses that could be associated with a more isolated failure. So what graphs, I think, do from a data modeling perspective is they offer the opportunity for a sort of higher level of intelligence in terms of the way in which systems represent and permit analysis of information that very often is already held, and banks are great places for generating enormous amounts of information, but information which is held but often not very well understood, or not understood in a connected or connected fashion, not understood in conjunction. So I think very likely everybody on this call is familiar with the uses and the achievements of relational databases, which are an astonishing and hugely important technology that underpins the entirety of modern commerce. And we have a great deal of data which has very well understood data structures. It's strongly described from a schema perspective. There are known problems and very repetitive queries against that data. And also, and I think this is the most important part, where connectivity of information is frequently either something that happens temporarily in the course of joins, or it's something that's seen as being part of the sort of the referential integrity, the robustness of the data. But it isn't necessarily foremost in people's minds when it comes to the kinds of problems that are being addressed, the kinds of questions that are being asked, or the kinds of algorithms that are being exercised over the data. Whereas graph databases, first of all, have a schema optional character that one can impose certain constraints on the structure of the graph, but there's also the ability to actually evolve the graph in a quick, rapid fashion relating to business changes, application needs, and so forth. And also, I think, centrally, graph databases are organized around a materialized representation of connections, of relationships, of edges between nodes in a, the sort of mathematical sense of the graph. And where those relationships are first-class problems or first-class items of interest, graph databases are very relevant. And so it's an evolution, and in one sense you could say that there are graphs kind of embedded or implicit in relational databases, but they're surfaced in the graph database. Now, Neo4j has a lot of interesting characteristics as a product. One of the areas I'm responsible for product management is the language that's used to access Neo4j graphs. It's a language called Cypher. I wanted to mention it because I think that it's an enormously powerful tool for very concisely expressing complex questions about data, and it does also have an update side so that Neo4j is no LTP database with transactional characteristics. One can modify data, create new data, and all of that in the Cypher language is oriented around the concept of patterns which model nodes with relationship to other nodes and let you make statements about which nodes you're interested in, which relationships you're interested in. So these are the equivalents of what can be extremely complex join statements in SQL, for example, but very concisely presented and very, I think, intuitively presented. It's not this, the rendition of this particular query isn't particularly great because it's a long match statement, but that match statement includes a very complex pattern about interrelationships. And so Cypher, I think, is one of the key things that enables users of graph data to have the familiar capabilities of a language like SQL, but one that's very much adopted or pointed at this kind of problem space. And I guess before sort of getting into some more specifics around the sort of financial services, the kind of data we see in financial services, the kind of graphs that we see in financial services, it's probably just worth taking one step back and on the point of digital disruption, if you like, or what's happening to people thinking about how to re-equip technically within finance. In a sense, databases like Neo4j are about democratizing developments that have happened, particularly in the sort of technology industry, where the use of graphs has been absolutely fundamental to the growth of some very large companies which have displaced competitors, which use sort of more primitive technical approaches, if you like. PageRank within Google would be one of the most classic examples of the use of graph algorithms driving a tremendous commercial success. LinkedIn, Facebook, the whole concept of the social network is a graph problem, and we've seen in finance that companies that utilize graph technology have actually been able to eat into the historical position of better established financial services firms. So Neo4j is a tool which is very widely used by thousands of users, hundreds of paying customers, to gain easy access to some of the graph capabilities and to actually provide a platform for the exercise of things like graph algorithms in an easier fashion. So moving on to a more sort of finance-specific view, and inevitably this is pretty schematic, there are 5 key graphs of finance you can think about. This is semi-arbitrary. They actually overlap with each other. I'm sure that all of you in the audience will see holes in the way in which this is being presented, but it's an attempt to sort of distill some of the key areas where graphs are relevant. There's the assets, the customers, the transactions, there's master data, and if I press the down key properly, there's also the whole area of access control, of entitlements and access to data. So I wanted to sort of look at these in turn and just sort of highlight some of the the ways in which those kinds of data viewed as graphs can be leveraged to address common problems in FS technology, starting with the asset graph. So we have a whole number of bits of information that relate to the kinds of products that FS companies originate or purchase, the positions that they hold within those different products or instruments at a given point in time, the information that then has to be understood in terms of pricing, whether or not this is real information or whether it's scenario information, the kinds of routine calculations that have to be carried out in terms of valuation, risk, the variations over time of that data, the control environment that surrounds that information, the reports that need to be made on things like transactions or regulatory risk reports, capital reports, and so forth. This is a very complicated set of interrelated data, and actually understanding the current position of a firm, the position of a firm and, under the impact of different events, whether they be market events, credit events, the possibilities that will have to be demonstrated to regulators in terms of stress scenarios and so forth, put a huge amount of emphasis on this graph, on the understanding of all of those kinds of relationships. So I think that that's something that an area which is, we can see very clearly that this familiar picture of an enormous amount of data, documents representing transactions, data sets representing all kinds of derivations, highly connected information but independently generated. It's just evolved, and the systems have evolved that generate this information, so that there are graphs here, and they're very valuable pieces of information, but they're implicit. And I think that one of the things that we can think about a graph database as providing is not anything magic in terms of replacing some of the characteristics of relational operational data stores or analytic warehouses, data lakes, and so forth, but a different kind of database in the sense of a higher level database, more intelligence, more understanding, and more information, a kind of data brain. And I guess one way of thinking about that is that we often think historically about graphs as dependency graphs, where we're trying to work out what are the components that lead to the generation of particular numbers, for example. But imagine that extending way beyond sort of conventional understanding of a dependency graph in pricing and risk, and be able to model and catalog and control and carry out the what-ifs and the reports of the data flows and processes that are so fundamental to the everyday operation of financial services firms. And the work that I did in Barclays, for example, around enterprise data integration, we were trying to build a control framework and an understanding of, from many, many dimensions, of the way in which our systems interacted, our intraday systems interacted with our end-of-day processes, and to be able to keep control of that, to be able to report on it, and to be able to understand in a much more complete way where we had problems, where we had gaps, and so forth. And that was actually the problem space that first drew me to looking at graph databases and actually ultimately coming to join Neo4j. I thought there was a very strong and obvious connection between the graph model and the kinds of problems that are faced within this sort of context. I think the customer case is reasonably familiar as a big sort of focal point problem that lots and lots of firms have been working and are working on in terms of trying to actually create a single view of customers and interrelationships. And you can see I think the animation on this is gone to sleep. But, this is an example of a way in which data relating to corporate entities. Oops, that's just let me come back on that. Understanding of corporate entities, corporate structures, and so forth can be thought of as a graph, and I think we all know both from our world of financial information relating to our internal organizational structure, legal entity understanding about our counterparties, etc. That's an extremely complicated set of data with the absolute characteristics of the graph that there are interconnections running in all kinds of directions. And you can see the same thing if you look at issues to do with the sort of application of that kind of information with things like anti-fraud or anti-money laundering, that tracing relationships with people and legal entities, politically exposed, significant persons, all of those kinds of issues require an enormously complicated data set to be maintained. And I think the applications of that in terms of things like exploring market opportunities, the opportunity to upsell and cross-sell to existing customers, recommendations, but also things like credit risk and credit control, fraud detection, anti-money laundering, and I think an increasingly important theme, reputational risk. Who is the bank actually dealing with? What are those customers and what kind of relationships might they have? The transaction side of the picture is obviously, fundamental to the operations of financial services firm. Everything derives from the acquisition of, or the assets and liabilities that are created through those transactions. And this is a focal point for the way in which banks can be, abused as vehicles for things like money laundering. So there are transactions that are wholly legitimate, and then there are transactions that are being used for all kinds of other purposes. So not just in terms of some sort of, the kinds of applications where we're looking at examining trading, the actual process, for example, of trading, but also post-trade activities and compliance inspections and trying to increasingly intervene in real time to prevent fraudulent activity or to detect violations, whether they be at the credit level or whether they be on something that's to do with malign behavior. All of these things involve these very complex structures. That transaction graph and payments being part of that picture, again, I think that we can see overlapping benefits, and applications to some of the other data graphs that I've already referred to. The master data case, there's lots of angles of view on this. One case, the sort of whole notion of an enterprise architecture in the broadest sense, to actually understand everything from the underlying physical infrastructure of the organization, the applications that exist, the data flows that exist, the projects that are in flight, the impact that the change analysis, impact of change, understanding all of those things involves managing a set of information which most organizations find very difficult to actually assemble and to maintain in an up-to-date fashion, and it is intensely graph kind of data. And data models and flows and governance, I think, are a particularly strong point of emphasis. Reference was made already, I think, to the kinds of reports that are needed and the demonstration that needs to be made under regimes like VCBS 239, in terms of having risk under control and having the data on which risk judgments are made under control. All of those issues come under the sort of aegis of this master data notion, as well as information which that builds on basic customer information, like the legal entity kind of problem, hierarchies, etc. And then I guess finally, just talking about the access control or security aspect. I think access control is one key part of the picture of protecting the assets of an organization. There are frequently very complicated problems in terms of identifying all the characteristics that should or should not allow access, and the problems that are involved in provisioning access and deprovisioning access across many, many different systems. Very difficult to achieve that in a timely fashion, and to actually build those identity and access management solutions readily from much existing technology. And we see in Neo4j many, many organizations using graph databases as to enable complex entitlement or access control capabilities. I think that that's something that is obviously the whole issue of, of security, of cybercrime, of protection against those different possibilities. This is something that links into that. It's one part of that very complex, broader picture, but it's certainly something where the graph database can be applied effectively. And I guess it's, mentioned most of these points. I think that the compliance point and the reputational risk point again arise around this. Access violations are not just a problem in terms of what they actually can cause, the trouble they can actually cause, or the possibility of of financial loss, but the reputational risk of any kind of large-scale breach of security, I think, is something that's very high on the minds of financial services firms. So I just wanted to finish with the following sort of thought, that the graph data model is really the sort of superset model. It's the model of information that lets you not only look at all the things you can see in a relational database, but to look much more at the connections as well. And it kind of surfaces from the relational database a newer set of capabilities that have been latent or implicit. So these comments from Gartner, I don't know, I think this goes back to about 2016, so I don't know whether it's true. By the end of 2018, 70% of leading organizations will have one or more pilot or proof of concept efforts underway utilizing graph databases. But we are certainly seeing an ever-increasing level of interest in using graph databases, and I think this is something, a technology that, although still relatively young and relatively small in terms of sort of database market share, is most definitely something that it would be worth any firm within the financial services arena actually looking at and determining whether it might be something that could assist their operations. So that's a quick sort of run through of some of the issues that I think we face in this particular industry sector, and I'd like to hand back to Nick and the other and Richard at that point.
Hello, so Richard Pike here. So I'm the CEO of Governor Software, and I'm going to have a talk about how we use Neo4j graph databases to address the oversight problem within the governance space. So Governor is a RegTech software firm, and our aim is to provide intuitive, auditable, and flexible oversight software for senior executives in the financial services industry, both in the US and in Europe. So what I'm going to just describe to you today is a little bit about the problem and then how we go about solving it. So as the guys before were saying, there's a huge expansion in regulatory obligations in financial institutions, particularly since the crisis. And as a result, these financial firms are having obligations, in effect, set by those regulators, but also by investors. And there are myriad of them. You can see there in the quote from Corlytics, since 2009, 54,000 regulatory documents have been issued around the G20 countries alone. The other thing that firms are doing is they're taking those regulations and obviously creating policies which set internal obligations, but they also have their own strategic objectives and internal goals and budgets and all that sort of stuff. So you end up with just a monstrous amount of obligations that any one person working in the senior executive space in financial services is aware of, trying to make sure that they get oversight of. So moving along, in effect, the process of governance and oversight is saying that it is now becoming incredibly important. So what's happening is, since the crisis particularly, the regulators have said that if you're acting in the senior executive position in a financial institution, you have to really understand the risks you're taking, the compliance problems you have within your business. And so, in fact, what they have realized in the regulatory space is that not every firm is going to be 100% compliant with all of the laws all of the time. But the key is that they understand where they aren't and what are they doing about it. So if a regulator comes in and does an audit, if they feel that you were on top of things and you understood what was going on and where you're having issues and not having issues, that's pretty good. Whereas if they find a problem and you didn't even know about it, they're really going to come down hard on you. And this has got specifically worse, so we say, from a couple of things. So in the UK, there's a thing called the senior manager regime. It's now having senior executives attest and sign away that they understand the risks and the things going on in their line of business. And there's, you know, individual personal fines and jail times at the end if you can't prove that and you're not happy to sign off. The other thing that, happening throughout the world is individual directors and senior managers attestations. So I myself am a non-executive director in a number of banks, and on a regular basis I would have to sign off that I understand the liquidity position of the bank or the capital position of the bank or any number of things to do with the regulations. So again, I need to make sure that I have really good oversight that the bank is doing what it says it is in terms of compliance regulations. And so let's just look then at what that stands up as a problem in a bank. So what you're really doing then, in effect, is you have these unstructured or semi-structured regulations coming to you in the form often of PDF documents, but if you're lucky you might get an XML document from a regulator. You also have internal documents around, you know, policies and all this sort of stuff. So it's unstructured in general. The data telling you that you're in or out of compliance is sitting in relational databases, it's sitting in transactional systems, it's sitting often in Excel spreadsheets or PowerPoint, to be honest with you. So again, it's in various disparate systems in various different formats. It's also generally in different dimensions. So the regulation will come in terms of a regulator, a jurisdiction, a type of entity, a banking license or an insurance license. But the data you hold in your bank or in your insurance company is going to be by line of business, by legal entity, by product. So again, there's an entire mapping exercise between what are the obligations I have to have oversight of, and where is the data and in what structure is that data to prove that I'm in or out of compliance. And you can see there in a quote from the Financial Times the level of cost that process is now giving the banks. And not only is it costing them a huge amount of money, but actually, relatively speaking, they're not doing it very well either. So you can see there from the terms of the fines they're getting. And so that's providing a real difficulty and a real challenge in the banking space. So if we move on, we see that, in effect, we can boil down the problem to, I've got unstructured text in documents, and I've got to somehow link that to structured objects, but they're in various different systems around databases and spreadsheets. And when we looked at this problem, we realized that actually the graph database was the best way to solve this particular problem. Because, as Alastair was saying earlier on, there's this natural linkage that comes with the graph database. And we honestly did try and do this originally with a SQL database and failed entirely because of this ever-changing nature and sort of amorphic view that you have to take of these regulations and these internal items. And so we chose the Neo4j database. We chose it for three real reasons. We chose it for flexibility. We chose it for secure and auditable, and obviously for large volumes. But to be honest with you, the volumes here are not monstrous. When you take, it's not really big data, because a lot of this is it's big in terms of there's a lot of regulations, but we're not talking of millions or billions of rows. So the biggest graph we would have seen around a set of obligations and their metrics would be 18,500 nodes, which is big when you're a senior executive trying to figure out what's going on, but as a database engine, it's not rocket science at all. So then in terms of what we went off and built, so we built a product. If we move on to have a look at what we did. So we had to build a solution that was able to be put on-premise within a particular financial institution, because they won't want to put this sort of data on the cloud just yet, to be honest with you. And so we put together a Neo4j graph store. We built a Java server application on top of that. And we were able to then link some applications to that. So we can link that to customer applications through an API, which allows us to get data into the graph database very easily and then very flexibly. And we also did individual links to things like SMTP email servers so that we can use workflow and do things like that. We then used D3, in fact, in this case, to build a user interface application so that we can actually allow the users to draw the graph and then also to show them the results of the graph and various things like that. Then we built what we call a map creation utility, and this is one of the key differences that we had and the challenges we had in this process compared to, I would say, usual graph database solutions. In most graph database solutions, you will take the data set you have and create a graph that represents that data set, which is normal. However, we're doing things slightly differently. So we had to create a data set in terms of one half of the problem, which is what are the regulations. So we had to have a way to ingest these regulations as maps, as we call them, or graphs. But then we wanted to build on manually where is my data in the bank that matches my obligations. And so we had to build a map creation utility to ingest regulations, which we now have done. And then we basically were able to give the users both a web browser in terms of access to the data, but also a mobile app so they could access data when they were out and about. Then in terms, if we were to move on and see the sort of challenges we had to do. So as I said, the real challenges around this issue of instead of using the data to create the schema, we had to allow the user to create the schema. So we actually had to build a meta model of what obligations, metrics, risks, policies, and so on and so forth. What are the core items, in effect, and what relationships are up to you. You build them yourself. But what are the pieces of information and meta model information that I have to hold for each of those individual items? So we did design that. As I said, we had to design an interface for users to build the graph so that you can literally in our interface double-click and add a new policy or add a new control or add a new regulation and draw the graph physically, so we can allow you to do that. And one of the big challenges we had, and we got a lot of help out of Neo4j for this, is we had to build a time machine. So what we mean by that is a big requirement of the regulators is that they can go back in time. So they can ask you, as of the 1st of January 2017, what was your compliance status? So what we had to do was we had to keep all of the changes in the graph over time and all the comments and all the data we've arriving in from various places, and we could give you very quick access. So you could click on an item and go back and see, as of the 1st of January, what was our world looking at like. So we did that, and that was tough to do, but very, very pleased to get it done. We had to design, obviously, a way to get data in and out of the system using APIs. We also have Excel loaders because it turns out a lot of bank data is sitting in Excel, so we did that as well. And then we had to basically give an interface for people to view and comment upon and look at the data that it's giving to them. So it had to be secure so that individuals could see one part of the organization and not another, and give them a really nice interface to use the data. And then finally, we had to do all of this in a really secure, stable environment to be installed on the client side. So there's no, we don't use, we don't host this as a SaaS thing or anything. It has to be, setup.exe sort of thing installed within the client site, and has to be secure, stable, and very, very tight environment. So that was a long process. It took us about a year, and here's what it looks like. So this is a regulation. This is actually a New York Fed regulation around anti-money laundering. So we can see us drilling down here to an individual obligation, subsection C4. I can see there on the right what is that obligation from the regulator. And then under indicators, I can see what are the things we have internally that help us to prove we're doing that job. So we've got a couple of policies. If I double click, so there's the two policies, and I've got a monitoring policy here. And there's the detail of that monitoring policy, and I can read fine detail of exactly what that policy is. So that is the piece of policy that goes to that piece of the regulation. I then have a control on that policy, and I have a metric here, which is the number of open issues. And so you can see the control, and then I'm saying, well, if I have more than one issue, I'm going to have a problem. And there you go, there's the data item 1, and that's why I've got amber, and then amber is rolled all the way up. But I can also go back and double-click monitoring, and I can see, well, let me roll up by policy. And so if I click this, you'll see at the top of the line, I have the AML policy. So now I'm looking at the world in a different view, which is by policy, and I can see the policy document and all that sort of stuff. And then I can say, well, look, I want to look at this instead of by regulation, and there's all my other types of items. I'll pick policy. So I want to look at the world by the policy. I can apply, it'll empty that out, and then it'll redraw the world, so to speak, by policy. But equally, I could redraw by business unit or by product or whatever. And so there's my policy, same data, but I can now see how the amber flows up to the policy. Then on the right-hand side, I can see that a day ago I had a problem with the policy, and there I can click on that. On the left-hand side, you see the actual history. So I have the time machine so that I can go through that item. Okay, so very quick view. If we go on, that'll go around in circles. So in effect, that just shows you how we've used the graph to allow much more flexibility in terms of that problem of how do I match the regulations and the obligations I have to the internal data that's sitting in multiple systems around the organization. And we must say we found Neo4j to be really excellent in that, and support, particularly with the development that we've had to come through, particularly the time machine, to be honest with you, has been really good. So thank you very much.
Right, thank you very much, Richard, and to Alastair. So we're going to now go into the Q&A session. So the first one I've got, and this could be open to both Alastair and Richard, are graph databases not a logical subset of object databases in that they model the structure in a similar way, but without possibly encapsulating the behavior? I don't know if Alastair will. Okay.
Yeah, it's Alastair here. Well, yeah, that's kind of an interesting point. I mean, the nature of the representation of the information and the fact that you have the ability to hold complex objects or complex data structures, I don't think is really a differentiating point. I mean, in fact, you could say that there are no inherent restrictions in a graph database on the kind of information that you actually store in properties. And you could, there's a couple of angles of view on this. You could say, for example, that if we have complex object being stored that can be retrieved, and then we can actually look at it as an object, and we just sort of think of it as an object in, object out, you can do that. You could also model some of the internal relationships complex object and actually see some of the internal object hierarchy within a class hierarchy within such an object. But I think that the thing that from the graph database perspective is the emphasis on the interconnections and the nature of the kinds of information that's stored, or the way in which that information is structured doesn't really sort of, that doesn't address the issue of the relationships and the connectedness, which is where I think the real differentiation comes. So you could evolve, you could have a graph database which is much more sort of thought about in terms of thought of as a kind of an evolution of an object database. And I think there is a whole interesting area that will, as the graph database world matures, I think we're going to see more and more of more sophisticated concepts of typing, more sophisticated concepts of schema, while still retaining schema optionality. And these are things that you could certainly sort of important thoughts about how graph databases could expand. But I think the key point still remains that ability to focus on complex relationships.
Yeah, certainly from my point of view, without getting into the technology side, pure and simple, it was really, when we looked at the problem, we realized that we had to make things in some dimensions somewhat simpler. So yeah, if we wanted to really look at those objects we're talking about, be they regulations or policies or controls, we could spend, you could write a whole system for each one, right? They're very complicated areas. So for us, it was about actually the relationships and our idea of red, amber, green, and making the interface readable, so to speak, was more important almost than understanding every detail about the object. So for us, the graph database made a lot of sense in terms of that focus on the relationships and the linking, where the real business value comes, as opposed to being able to model each of the intricacies of each object that's sitting within within the map, as we call it. So the graph database in that regard is more than enough in terms of that side of complexity.
Okay, thanks, guys.
Nick,
So the next one here.
Sorry, Nick, before we go on to the next one, I see one of our audience raised their hand, I think, to ask a question. Unfortunately, we can't open their line, so if they could type it into the Q&A box, and hopefully we'll be able to take that after the next question that you're about to do, Nick. I do apologize. Please go ahead with that question.
No problem. Thank you, Hugh. So the second question, Alastair mentioned schema optional databases, and Richard mentioned creating a meta model up front. Is Neo4j going to add increased schema constraints over time?
Well, I guess the short answer is probably yes. I think that what we're actually seeing as the usage of Neo4j expands more and more into enterprise customer environments, and that would certainly be applicable to the sort of financial services arena. There is, you see both sides of the picture. You see sometimes environments where it's very important to be able to actually rapidly take data that's very disparate, to be able to think about it more from a kind of schema on read. It's the application's view of the data that really brings it together into some kind of data model. And we also see increasingly that people are using Neo4j more and more widely in environments where there is actually quite a lot of regularity and common structure to the data. There's applications being built around that data that has very regular access paths and so forth, and is much less ad hoc. And we're also hearing from customers, and we see the value of this ourselves, that while we want to retain this important concept of schema optionality, we'd also like to increase the ability for classical data modeling techniques to be applied. I mean, to take one angle of view on this, an entity relationship diagram can be translated directly into a graph database. With relational data modeling, we have to go through tricks like creating join tables, for example, in order to achieve that. But the graph database is actually a very direct translation of the sort of true underlying data model. And at the same time, with Neo at the moment, we have some degree of constraints relating to indexes, to properties that are associated with labels, but there are more complex elements of schema constraints, like controlling which kinds of nodes can be connected to another kind of node, or the cardinality of those relationships. Where we certainly think that it'd be interesting to evolve, and that's something that we're looking at both on the sort of cipher language front, and we're thinking about in terms of the evolution of Neo4j as a product. So Neo4j and graph databases are relatively young technologies, and there's a lot of work been going on and continuing to go on to bring them into a sort of full enterprise capability. I mean, a lot of work's gone on over the last couple of years, for example, in terms of security characteristics. So yeah, Neo4j is I think it's an amazing product, a very interesting product. People have done extraordinary things with it, but there are also many future evolutions to come, and I think that area is one.
I mean, obviously I'm not involved in where Neo4j goes, but from my side, an interesting challenge I have now coming down the track is, so we have a regulation, as I showed you, mapped, and then the bank says, well, this is how our internal systems and processes are linked to that. Clearly the regulator will change the regulation in 3, 6, 9 months. So we need to be able to update half the graph, so to speak, yeah? So the pieces that we deliver as what we call content. So we are increasingly looking at how do we create but fix parts of the graph, and then allow flexibility in other parts of the graph. And so that's the sort of challenge we have in terms of it isn't from the underlying Neo4j, but from us as a product. We're also challenged with that problem of how flexible do we allow our clients to be, but how do we hold them to account in certain things they can't change, because otherwise we wouldn't be able to update it. So we have a similar challenge on the product side.
That's interesting, actually, because another thing we're looking at, and I think we'll be bringing in first with Cipher operating in a Spark environment, is support for multiple graphs. So the ability to have different named graphs, to segregate your graph database run queries which could take multiple graphs, combine information from them, generate a third graph, and so forth. And I think that will actually help provide more flexibility and maybe the sort of differentiation between different kinds of graph. I mean, I don't know whether that would actually be relevant to what you're looking at, Richard, but it's...
yeah, it might be. I mean, we allow, so the way we hold one graph in the background, but we actually allow multiple maps, as we call them, and we can interrelate maps. So yeah, I mean, that you know, I know the stuff around indexing and other stuff you're doing. So yes, we're watching as you do, and that sort of stuff would be really useful, because also we have in multiple clients who will come together and say, there's parts of these graphs we want to share because they're not competitive. We want to see what's going on here. And others where they want to hide them away and leave them on their own. So absolutely, we're going to be interested in how we can effectively import, export, and merge graphs over the next year or so.
Yeah, yeah, we're seeing a lot of that kind of discussion, I think. Yeah.
Okay, thanks, guys. On to our next question. I have here, what is the best way to start learning Neo4j?
I reckon, Richard, that you might have a better view on this than me, because I think you've really built a system for Neo4j.
Well, in my case, yeah, the programmers are pretty answered with, get a phone call from a guy who said, he'll pay you X if you get this to work. And then they just opened the book. I mean, I do think that Cypher was a big reason for us picking Neo4j, because it is relatively similar to SQL. So the programmers that I use hadn't seen graph databases before. They'd understood the maths, I think, but for them, picking up Cypher, and they're now 2.5 years in, was not a crazy thing compared to the SQL. You know, the difficulties they had were more around the benefits and how to really use Cypher really well, and that's probably taken them a while, and they're still learning. But I would say, you know, sit down with a use case and just start writing the Cypher is the best. And that's certainly the way we did it. We just got stuck in. We did a POC in about 3 months by just literally saying, off you go, let's have fun. So I don't think there's much, you know, there's good stuff online, but that's the best way to do it for me that I've seen.
Yeah, and we put a bit of effort into, you know, trying to create easy to use sandbox environments to help people with that kind of experimentation. But I think that the sort of two areas of data model and then, you know, using Cypher to experiment with queries. One of the things I liked about Neo4j when I first looked at it was how easy it was to actually sort of interactively prototype queries with the browser, and that's something that is, you know, it's a great facility, and there's new things coming down the line in terms of expanding on that as well. Things like graph editing, be able to do that interactively. So we're trying to sort of build up tools that make it easier to sort of come at the graph from whatever angle, whether you're a developer, a data modeler, and so forth. But the general sense I have is that if you are familiar with relational databases, or you're familiar with object-oriented or functional programming principles, you'll find you're in a kind of reasonably familiar environment, and that yes, there's a jump, but you know, and there's a jump around some of the actual potentialities of the graph data model. But the sort of steepness of the on-ramp, I think, is not that bad, and I think Cypher plays a particularly strong role, as you said, in helping people, you know, not have to look at the details, but make the declarative statements about the way in which they want to interact with the database.
Okay, and following on quite nicely from that, I think you both touched on it a little bit, but I'm sure this is a question that a lot of the audience will be interested in. Why would you want to use Neo4j against other NoSQL databases? How does it differentiate?
I don't know, Richard, it sounds like you went through sort of a kind of
we did
technology selection process. You might be...
Yeah, we did. I mean, I wouldn't say it was the most formal in the world, but we looked, we actually looked first in terms of NoSQL at the likes of Mongo's document stuff, because we felt we had a lot of documents, which we do, and stuff. Our difficulty, honestly, there was we couldn't control the environment enough. So that was too far away from a primary key SQL database. So that we just got our knickers in a twist very quickly with that around trying to get time, back in time, and hard links that we couldn't mess, and also security to make sure it was secure. We then looked at graph database, looked at a number of them, and to be honest with you, Neo4j was just the most stable and enterprise ready. And the other thing, which was an issue for me, was purely one of reputation. So, selling into a bank is difficult enough without adding technology they've never heard of before, and Neo4j are fairly well known in the banking space already. So that just helps. So, as I say, not the most formal one. We certainly fairly quickly got to the graph database as opposed to other NoSQL databases. And to be honest, Neo4j was really a pretty quick decision in terms of Cypher, because it's so similar to SQL, and the stability, and then the fact that you're pretty well known in the market.
Yeah, and I think that, undoubtedly, document databases, for example, like relational databases, have a very strong role to play. But with graphs, you have lots of, it sort of goes back to the object database question, you have lots of information which is connected, and document databases are organized around portions of very connected data, intensely, tree-structured data, can be extremely complex, but interrelationships between those documents are not the strong point, and that extends to the problem that, and this is something that Neo4j has had to deal with sort of from the get-go in this evolution, is how do you actually transactionally update a graph? How do you make sure that you never have a disparity between like a half edge, a node that should be connected in but isn't yet connected in, or we have a failure and it actually can leave the graph in that kind of inconsistent state. And so every time that we've seen attempts to build graph functionality on heavily sharded, key value stores or document stores, you hit that problem, and the problem of actually rapidly accessing and analyzing relationships, and then maintaining those relationships in a transactionally consistent way. Very, very difficult on that underlying technology platform. So there are graph features, as it were, that people have built on top of those kinds of stores. But if your interest is not only having pieces of information which are internally complicated and internally structured, but you want those pieces of information to be related with each other, then I think that the graph database can most definitely play a role. There's a counter side to that, which is that it's actually very difficult to arbitrarily partition a graph or partition a graph as it changes over time. And that's something that for us in Neo is sort of one of the big outstanding, we're working on that, very actively on that, but to get the extreme level of horizontal scaling and sharding that can be achieved with a key value store or a document database, for example, is a very tricky thing to achieve with graph technology. So I think there is I don't think we in Neo think that there is one technology that should be used from a database perspective, but we do think that the graph database has a very strong role to play, and that kind of point about it being a superset data model, over time I think that is going to become increasingly clear and increasingly applicable in terms of the way in which people use and select database software.
Okay, thanks for that, Alastair. Unfortunately, we don't have any more time for questions, so I'd just like to thank both Alastair and Richard for joining